So I know these are kind of hard to read. You may need to zoom in on your screen. But again, we are factoring. So just basic factoring first. If you have a strong background in factoring, and factoring is a piece of cake, then don't worry about it. Do it the way you do it. In a classroom full of students, 85, if not 90%, do not have a strong background in factoring. Or they are fine when A is 1, so that first leading coefficient is a 1, everybody's rocking and rolling. They do not when A is not 1 or not a GFC where we can pull it out and make it 1. So what I'm going to show you is the same way to do all of them. It's going to seem redundant for the first two because they are super basic. But again, I like patterns and things I can use every stinking time no matter what. The biggest thing I have to say over and over and over again is most Math 3 students, you've done so much factoring and so much math. The big thing you forget to always look for first is GFC. So greatest common factor. Always look for your greatest common factor first and foremost. Always, always, always. See if I can simplify. It makes your life easier. You do always have a calculator, but still, if there's a number that will go all the way through or a variable that we can pull out that goes all the way through, it makes everything a lot more simple. So first things first, if your first number is a 1, then there is no GFC. So GFC check, we're out. There is not one. So I went around Pinecrest and asked 100 times what they all did in common as far as teaching factoring. And the only thing they all did in common was the ACB chart. This is what I call Big Star. It's my favorite way because I realized it works for all trinomials, so 3 terms, quadratics, if it is factorable. Even if you forget to take out your GCF, you'll get to where you need to be if you just need solutions. Again, depending on the questions. But, so, first and foremost, at the top of our Big Star is going to be A times C. At the bottom is going to be our B value. And in the bottom lower corners, you'll always see it as P and Q. It's the factors. So these are the factors once we find our factors. And we're going to back up. I'm going to show you what all that means in a minute, just kind of setting you up here. And then from there, you have up in the upper 2 corners, I need a different color. There it is. A times X. So whatever your A value is with an X beside it. Whatever your A value is with an X beside it. And when I say A, B, C, and all that fun stuff, I'm all referencing AX squared plus BX plus C, which hopefully now that I'm reminding you, if you did forget, you remember that. And that means that we have to find our A value, which relative to this function is a 1. Like I said, it's going to make this seem really ridiculous, like a lot of work. But our B value is a negative 12. And our C value is 35. Again, using this outline to this problem. If I fill that into our Big Star over here, A times C, that's 1 times 35, means I'm going to get a 35 right here. Our B value, we do think is a negative 12, or we do know is a negative 12, which is perfect. ACB chart is the same as these two. So the sum, and then we have the multiplication. ACB chart, most students where they can get confused is I want what multiplies together that will add or subtract. So I need to multiply to give me 35, and then I'm looking to see if it add or subtract to give me a negative 12. Some teachers make you write out every positive negative combo. If that's what you need to do to get it correct, do it. I do not personally think it should take that much paper. So what I'm going to do is look at all of my factors for 35. Now, if you have access to a TI-84, and you can do it in Desmos, it's just not as quick and easy, is if you go to y equals, and we're just going to pretend like 35 is not a terrible number, but some of these numbers you're going to get are going to be kind of ugly. So 35 divided by x, write that in the corner of your paper somewhere, because I'm still fighting for us to have calculators in class, even if it's just a virtual format. But on the test day, you will have an actual calculator and Desmos. I did say this in Math 1. Do not all of a sudden think when you get handed a TI-84 because of the lack of time you spent on a TI-84 that this little sucker is God. If you ask it a question, it will answer it within the knowledge that it has. And we have not a lot of practice with TI-84s, most of us. So just be careful. Not saying don't use it, just don't all of a sudden like disregard everything else you've done because you got a new toy. So only use it when you remember how to make it do what you need it to do. And if you ask one of the teachers in the room, they will not be able to answer you. So the only thing I think at this point so far that would be very beneficial on a TI is be able to find your factors of whatever A times C is. So if I do that number divided by X and then I hit second graph, I get a table. All the whole numbers are my factors. And And I'm not sure you can see it because the screen is so small. But obviously, we have 1 and 35. And then 2 is no good. 3 is no good. 4 and then 5 times 7. And then the next one is 7 times 5. So as far as I'm concerned, you can stop there if this makes sense to you. Now, if I add 1 and 35, and my lines are getting kind of close together, sorry, is 36. If I subtract them, I get 34. Neither one of those are negative 12. If I add 5 and 7, I get 12. If I subtract them, I'm going to get 3. And positive, negative, again, we'll discuss that in a minute. The number we were looking for was that 12, and we'd like it to be negative. So 5 times 7 will give me 35, and we need that to be a negative 12. So that means that both numbers, so one way, again, depending on how good you are at this, I always put the big one in the front, little one in the back. If B is negative, the big one has to be negative. Has to, every stinking time. If B is negative, your largest number of the two factors has to be negative. Now, a negative 7 times a positive 5 is going to give me a negative 35. So we need them both to be negative because also a negative 7 plus a positive 5 is not going to give us that negative 12. So that's how they're both negative. I may be over talking for some of you at this moment. Just bear with me. Our A value is 1, so it's 1x, 1x. Now, hear me out because I've heard math teachers come unhinged when I say this. This is not a fraction, but we are going to pretend that it is a fraction and see if it can be reduced. Again, when A is 1, not as cool because we don't need to, it's not going to reduce. Then these are going to fall down, like the whole fraction like falls down like a building, and it's going to be x minus 5 is one of our factors. This one, again, 1 and 7 cannot be reduced, so it's going to fall over, and the other factor is x minus 7. And now I have factored this completely. I'm going to come over here to where there's some extra space. So x minus 7, x minus 5 are our factors. Now, you could go to Desmos, you could type in your question, the x squared minus 12x plus 35 in the first line, and your factors in the second line, and make sure it graphs on top of each other. That would be one way to solve it. You could also, as long as A is 1, put this in and see, hopefully, and this might be over talking again, that graph is going to touch at a positive 7 and a positive 5. We'll nitpick that later, but just depending on where you're coming from and what you got in your brain. Or you can multiply these back together like binomials, box method, FOIL method, however you want to multiply them back together to see if you end up back, depending on who taught you and forced you to check, because I know most of us, it's a force to check. All right, so ax squared plus bx plus c is our pattern. So in number 2, again, our a is 1, our b is a negative 2, and our c is a negative 8. And I just got rid of my negative. Negative 2, negative 8. B is negative. That's very telling. We're going to fill in our big chart. So A times C goes on the top. That's 1 times a negative 8. So that's going to be a negative 8. B goes on the bottom. B for bottom. It's going to be a negative 2. And then 1, in this case A. So A times X. So 1X, 1X. Whatever the A value is. And again, we're going to get down here to where this gets good later. We're going to look for our factors. The AC is negative 8, and then we have a negative 2. So multiples that add or subtract to give me negative 2. So add or subtract is your second column. So 8, we got 1 and 8, 2 and 4. 3 doesn't work, so then we're back to 4 again, so we have our sets. 1 plus 8 is 9. 8 minus 1 is 7. So we found their additions. Their sum would be 9. Their difference would be 7. Neither of those is what we're looking for. If I add these, I end up with 6. If I subtract them, I end up with 2. So now we have our pair because of that 2. Big guy in the front, just because that's my habit, not a have to. Because B is negative, I know the big guy is negative, and I need a negative 2. If I owe you 4 and I add 2, then I am sitting at negative 2. When we combine these like sum or differences, we're perfect there. And then a negative times a positive does multiply to give me a negative. Again, not a fraction. We're just pretending like these guys are fractions if they could be reduced. In this case, they cannot, so they just fall over. And that's going to give me x minus 4, x plus 2. Again, if you later need more help after you get through the next couple of days of notes, multiplying binomials back together, let me know, and we'll spend some time on that. Because right now, as far as I'm concerned, like I said, you can take this equation and plug it into the first line, and this equation and plug it in the second line on Desmos, and they should graph on top of each other, and you would know if you factored them correctly. And we're going to be doing a lot of this in the next 5 days. Okay, number 3, GCF is what we want to look for first. GCF is always the first thing you should do. So looking at each one, this is not a 1. I always try that value, whatever's the leading coefficient, if it's in standard form, which is that ax squared plus bx plus c, and see if it will go all the way through. 2 will go into 2, and it will go into 24 very nicely. So, and there's not an x in the back, because that's the next thing would be the variable. So I'll pull out a 2. 2 times x squared gives me 2x squared. 2 times a negative 1x, so that's just a negative x, gives me negative 2x squared. And then 2 times a negative 12. And again, this is just depending on who taught you this before me. That's the way my brain works. But ultimately, the other way I've seen people teach it is we take this and we divide them all. We put the 2 on the outside and divide them all by 2. And that's how we find our new function. All right, hang on to him. But we're not going to use him a lot right now. We're going to ignore him for a minute. Now, I will say math 1, at that point, a lot of people sometimes ignore it to the point of he disappears. He can't disappear anymore. We're in math 3, and we have to be very accurate. So our A value in our parentheses is 1, our B value is negative 1, and our C value is a negative 12. A, B, C. Again, this is that AX squared plus BX plus C. So A times C goes on top. A times C. So that's 1 times a negative 12. Negative 12. B goes on the bottom, which is our negative 1. A times X, in this case, A is still 1, because we pulled the 2 out and fixed it. We're going to come back to him in a minute. And then we're looking for our factors that will multiply to give us 12, that will add or subtract to give us 1. And if we're being literal, they're both supposed to be negative. So 1 times 12, 2 times 6, 3 times 4, and then the next one will be 4 times 3. So we have all 3 of them. 1 plus 12 is 13. If we subtract them, we get 11. 2 plus 6 is 8. If we subtract them, we get 4. 3 plus 4 is 7. If we subtract them, we get 1. And what we're looking for is that 1. So 3 and 4. So I'm going to put 4 in the front, little guy in the back. B is negative. He's definitely going to become negative. Negative 4 times a positive 3 does give me a negative 12. Negative 4 plus a positive 3 does give me a negative 1. So we're good to go there. We're going to check our not fraction. 1 over 3 cannot be reduced, so he's just going to fall down. So x plus 3, or 1x plus 3. 1 and 4 cannot be reduced. This is going to be x minus 4. Now, in math 1, a lot of times you would have stopped here and it would have been fine, because you were going to set it equal to 0 and solve it. But if we are just factoring, that 2 is just as much part of the answer as anything else. The 2 that we factored out up here, the GCF, don't lose him. He has to be in your final answer. It's going to be important. You'll see it later. All right, so again, 6, so there's a number in the front. We're going to try 6 all the way across first. And that's going to give me 1, which is we're hopefully going to do 6a squared. 18 is going to give me a negative 3a. And then 168, I wish I could tell you I could do it in my head. Give me 1 second. And that's going to give us 28. So GCF, 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 always think GCF first. I'm going to skip this one for the sake of time, because again, you're going to do the same thing, but the 1x is going to be on the top. And those are typically the ones that you guys are like, why am I doing all this work? I'm about to show you why, okay? Because that exact big star will work for everyone forward. Looking at number 5. So GCF is the first thing we're going to check. There's a 3 in the front. But 3 does not go into 1 and does not evenly go into 4. So we cannot pull out a GCF. So at that rate, we're just looking for our A, B, C values. So our A value is the number in front of our A squared. That's 3. Our B value is the number just in front of the regular A. In this case, is 1. And our C value is the constant. That constant will always be your y-intercept. I'm going to say that a lot, because the sooner you can get things like that through your head, you save yourself a lot of math. All right, so we have our A, B, and C's. A times C goes on top. 3 times negative 4 is a negative 12. B starts with a B, goes on the bottom. And that's going to be a 1. Now we want A times X. In this case, A is not 1. So that means we're going to do 3x, 3x. Now we're going to work on our ACB chart. Multiples are in the front. And that's 3. I'm sorry, a negative 12. looking at A, because this was A times C. So it's whatever numbers will give us a negative 12 that will add or subtract to give us 1. So this is the add or subtract column. 1 times 12, 2 times 6, 3 times 4, and then the next number is 4. So again, just like the one before. Wow, we have the same combos. That's crazy. So 1 and 12 is going to be 13 or 11. 2 and 6, again, will be 8 or 4. 3 and 4 are going to either be 7 or 1. We are looking for that 1 again. It's a different one this time. So 4 and 3. Because the 1 is positive, the 4 is going to be positive. For sure, I promise. Every time the largest one will be positive if B value is positive. Now we have to decide if 4 times 3, how I turn it into a negative 12. Or if I have $4, how am I going to get to $1? Hopefully you know that means I'm going to subtract 3 from 4 or make 1 negative, so when I multiply, I get that negative answer. Now hear me out. This not fraction, 3 over 4, does not reduce. So we're going to pull him down and he just falls out. 3x plus 4. That's as far as you can get. That's better than doing nothing. Now, not fraction, but we're pretending. We're just cheating the system here. I can reduce that 3 over 3. Now pay attention because we're not, again, it's not a fraction. 3 goes into 3 one time. X still exists. 3 goes into negative 3, a negative one time. Back in the day when we would actually do fractions, you would end up with a whole number. Again, not a fraction. We're just using it and pretending. But we have to keep a top and we have to keep a bottom. So now it's going to be x minus 1. X and the negative 1. Those ones are space holders. They have to be, because if we went down to just 1x, it would not give us back when we multiply this out the trinomial we need. So ones are space holders and they matter. All right, so here's our answer for that, guys. Any major pressing questions at the moment? I feel like the more we get through, the easier it'll get, but I just want to ask and make sure there's not something huge going on. All right, beautiful. Thank you for not leaving me hanging. All right, so I'm going to work on my big star. First and foremost, I need my A value. I'm going to check to see if I can DCF. There's a 5 in the front. 5 does not go into 14, so I can stop. There's not a variable in the back, so there's not a variable in all 3 terms, so I can't pull one of those out. So at that rate, we're just going to look for our A, B, and C. Remember, again, that's ax squared plus bx plus c, and that's where we're getting that A, B, and C from. A is going to be 5 in this case, B is a positive 14, and C is a negative 24. A times C goes on the top. So 5 times a negative 24. This is those ugly numbers that I was talking about, which would be helpful to have a calculator maybe. Just going to take a little longer. It's going to give me a negative 120. Our B value goes on the bottom. B for bottom. It's going to be a positive 14. A times x goes in our upper corners. And A in this case is 5, so it's 5x. 5x. We're going to look for our factors. And that's what's going to go in the lower corners. So A times C is a negative 120. So what can I multiply to get a negative 120? That will add or subtract to give me 14. All right, so 1 and 120. 2 and 60. 3 and 40. 4 and 30. Then I'm going to slow down probably. And use this. Again, you're going to go to your y equals. I'm all about saving that brain power for the really hard problems or the things that take that much brain power. So y equals upper left corner, number divided by x, second graph. You can use the negatives. It doesn't matter. Like I said, we're not really getting into that. So 5, 24, 6, and 20. 7's no good. Just make sure you're not 8 and 15. 10 and 12. 11's no good. So we're back at 12, which is going to give us out that 10. That's going to give us 121, 119, no good. If we add it, we get 62. If we subtract it, it's 58. We probably know, most of you, hopefully, this is how you would go through and pick, that 4 and 30 are never going to give me 14. It's not close enough. 5 and 24 is getting closer. That's 29 or 19. We got 26 or 14. If I subtracted them, these look good for that 14. But just make sure, because there's a couple combinations where there's a couple pairs, and the positive negative is what you have to decide. So 5 and 18 is going to be 23. If we add them, subtract it is going to be a lot less than 14 because we have 15. 10 and 12 will be 22 or 2. So none of those guys. So it is going to be our 6 and our 20. So only pair that matches. Big guy in the front, little guy in the back. B is positive. So 20 is going to be positive. And then from there, we got to decide what to do with our 6. We need a positive 14, but a negative 120. If I have $20, spend $6, I'd have that positive $14 left in my pocket. Now, again, not fraction, but we're going to pretend 5 over 20. Now, fun game. Some people, this is really hard to reduce fractions for whatever reason. And I love you dearly, and I can say it 800 times, and I can teach it like a math teacher. Probably no different than the math teachers before me. If you know that you struggle with this, if you go to Desmos and you type in 5 divided by 20, go to the far left corner of that line where you typed it. There's a circle with 2 squares over a division bar. Click it, and it gives you the simplified fraction. If you don't click that circle to the far left, like how you cut lines on and off when you're graphing lines, it will give you a decimal answer. Decimal will not work. We need the simplified fraction. But in this case, 5 does go into 5, and it goes into 20. So 5 is going to go into 5 one time. I'm going to hold on to my x. Remember, it's not a fraction. We have to have a top and a bottom. 5 goes into 24 times. And they're both positive, so it stays positive. 5 and 6 cannot be reduced, so that puppy's just going to fall out. Top guy in the front, bottom guy in the back. X plus 4. So top guy in the front, bottom guy in the back. There was no GCF. So you are finito on that guy. Done. All right, how are we feeling? Are you seeing a pattern at least if we're not super confident? A good handful of you guys I taught for math too, so you'll have seen this version before. Cool. Nice, nice, nice. Thank you for not leaving me hanging, talking to myself. I appreciate it. All right, do we want to do one more, or do you want me to jump to the next kind? Yep, absolutely. I've got pages. We can do as many of them as you want. I came prepared this time, not to have to make up any problems, so it doesn't make it hard on any of us. GCF is the first thing you want to check. There's a 7 in the front. 7 does not come out of 17 nice and neat, and it does not come out of 10. So GCF is off the docket. We cannot make these numbers any better. So we're going straight to pull our A, our B, and our C. A lot of you are going to fight me on writing this down. Guys, you're learning too much new math for you to make a mistake here just because your head hiccuped. Because if I ask you in person and slow you down, what is A, what is B, what is C, you have no problem. I highly recommend, especially on test day, write down the A, write down the B, write down the C, and then move over. Because otherwise you will magically make things up. So we have 7 as my A value, negative 17 as my B value, 10 as my C value. Top of the star, A times C, and that's going to be 7 times 10, which is going to give us 70. Bottom of our big star, bottom is going to give us our B. Upper corner is AX, in this case A is 7, so it's going to be 7X, 7X. And then ultimately, actually, as I'm telling you this, if you are in delta, if they use a variable other than X, you have to put in the answer with the variable other than X. I change it to X because my handwriting is trash, and N's and A's and all that fun stuff does not translate very well, especially when they're small on the screen. But when you are putting your answers in delta, slow down enough to make sure that you, and IXL, if we end up doing any of those factoring IXLs, they want the letters that they used. Okay. Uh-oh, it jumped. ACB chart. ACB chart. So that's 70. We multiplied to get 70, and we're going to add or subtract to get negative 17. I bet some of you already know which one it's going to be. So 1 and 70, 2 and 35, 3, no good, 4, 5, and 7, 8, 9, 10. I should know this, and I don't, off the top of my head. 14. 70 is no good with 6, so 7 and 10. Then 8's no good, 9's no good, back to 10 again. Perfect. So 71 if we add them, 69 if we subtract them, 37 if we add them, 33 if we subtracted them, 19 or 9, 17 looks good, or 3. So 17 is what we're shooting for, so we're going to take this pair. Big guy in the front, little guy in the back. B is negative, so I know the big guy in the front has to be negative. If I owe you $10, but you're telling me I owed you 17, so I'm trying to get here, then I have to take away $7 more. Also, a negative and a negative is the only way we can multiply to get a positive. And I'm saying all the different ways and the logic ways that you could get to figure out which one's positive, negative, because all of your precious little brains work slightly different. 7 and negative 10, not a fraction, cannot be reduced. So he's just going to fall out. 7x minus 10. Our other not fraction over here, but we're pretending because we like anything that makes life easier. 7 and a 7. So 7's going to go into both. That's going to be a positive 1x. Like I said, it's not a fraction, but we're pretending because we need a top and a bottom. So we have a front and a back to our factor. X minus 1. And you are now done. You have now factored this bad boy. All right, for the sake of time, if we have more time, I'll come back and work 8, and we'll do another one. Plus, it'll be nice to take a break because we're going to do something totally different. Now, that works for trinomials. That means when you have 3 terms, the standard form, ax squared plus bx plus c. Now, if you have a binomial, which means 2 terms, so things that have to work because you're going to think this is your favorite way to factor. Binomial is a must, means 2 terms. It has to be subtraction. And then it has to be perfect squares. And that means I can take the square root of that number. So I can use my square root button. So some number times itself twice will give me the number out. And this is called, in case you need to Google it or look it up or do more research, the differences of squares, or difference of squares. And the word difference is why you have to have subtraction. Of squares is why they have to be perfect squares. Binomial part is not in the title, but it's one of the, like, if it's not there, you can't rock and roll here. Now, starting off kind of difficult, so we're going to go to 10. What we're going to always do, hopefully we know by now, because I know at least those of you who had me, I repeated 100 times. Every time you take the square root of any number, there's always 2 answers. There has always been 2 answers, all the way back from Math 1 when you first started doing with square roots. Most of the context of Math 1, though, you're doing distance, or you're doing side lengths of a triangle, which is also distance. All positive. None of those could be negative. So every time you took a square root, you just didn't pay attention. The conversation was not for the negative answer. The conversation was only for the positive. But hear me out. Every time you take a square root, you'll have a positive and a negative answer. So with that said, if we can get it through our head, that means when we have a factor, we're always going to have a plus and we're going to have a minus. You're going to take the front one, which in this case is a squared. We're going to take the square root of a squared. What did I multiply times itself to get a squared? It's going to be a times a, right? So just like we're going to take the square root, and that's what it is. In this case, like if I did the square root of 4, it would be 2 times 2, so the answer is 2. Square root of 9, 3 times 3, just in case as I'm just jabbering, we forgot what square roots were. So square root of a squared is going to be a, so we're going to get a in the front, a in the front. Then we're going to take the square root of 25, disregard the negative. That minus is taken care of when we did the plus minus. Square root of 25. So what number times itself gives me 25? It's 5 times 5. So you're going to put a 5 in the back, 5 in the front and back. Plus and minus. Now you have factored it. Differences of squares. If I FOIL this or box method this back together, you should end up with ax squared minus 25. Now again, because we're Math 3, and this is actually a Math 2 concept, hopefully you remember some of it from before. I didn't leave you a bunch of easy ones. I just sprinkled them in there just so we didn't lose any steam. If the number is attached to the variable, it's the same thing. We're still going to do the square root. So first thing first, if this is all you can get down on your paper, as soon as you see one of these problems, please, because that's still a step in the right direction, and I will get you where you need to be if you'll give me what you got. So if you see a binomial, 2 terms with subtraction, and you think you can take the square root of both numbers, you should at least have a first set of parentheses and a second set of parentheses. We're going to take the square root of 25, which is 5. We already did it, right? You will also realize that a lot of the times when you take the square roots of these numbers and you see these problems, they use the same numbers over and over and over again, especially if you do a lot of them. Square root of 16. So what number times itself gives me 16, and that is that 4 times 4. So we're going to put a 4 in the front, 4 in the back, and you're out like shout. I left out the x, but in this case is a b. Sorry. Square root of 25, square root of b squared. Both combinations go in the front. If I multiplied 5b times 5b, that's going to give me 25b squared. And remember, if you FOIL or box method, this would be your first action to get here. So we're undoing that sort of when we factor. All right. 25b squared minus 9. So it's binomial, 2 terms, and a subtraction in the middle. So I'm going to go ahead and write my parentheses, a plus and a minus, because I'm hoping I can square root them. That means differences of squares, and I'll have a positive and a negative every time. Square root of 25 is 5. Square root of 25 is 5. Square root of b squared is going to be b, just like the one before. We're looking at our second number. The square root of 9 is 3 times 3, just like I did over here. So 3 and 3. Now, these can have GCFs. Let's see if I gave us one that's a GCF. I did not. None of these have a GCF on them. That's not very nice of me. So let's say if this problem, 3b squared minus 27. 3 is not a perfect square. 27 is not a perfect square. We cannot take the square root of either one of those numbers. But 3 does go into 27, so I could factor out the 3 and be sitting at v squared minus 9. Now I have a perfect, they're both perfect squares. There's a binomial, so I'm going to write 2 sets of parentheses, one with a plus, one with a minus, because I'm going to take the square root of each. Square root of v squared is v. And then we're going to take the square root of that 9 again, and that's your 3 times 3. And we're just going to bring that 3 back on the outside. So GCF can exist here as well. The faster you can get through your brain to always check for GCF, the easier all factoring will be, because it is allowed everywhere and at any point. And the faster you can get the numbers down to what you can manipulate, the better. Now, again, that is difference of squares. You did do that in Math 2, hopefully. You may have even done it in Math 1, depending on who your teacher was. Difference of cubes, difference and sums of cubes. So difference and sum of cubes. Now, I want you to think of a bar soap for cubes, okay? So this is going to be cubes. It's not going to be a perfect cube. We're going to think of soap, S-O-A-P, okay? The biggest misconception on these guys for most students is because this is to the third power, we are so used to in our previous math careers square rooting that we don't know how to cube root. So we know we have to do cube root because this is a cubed function. So it's raised to the third power, so we are going to use the cube root. That is not 3 times square root. That is a completely different button. I think on Desmos, you're going to find it under functions. It might be on the first page, actually, now that I'm trying to visualize in my head. In a TI 83 or 84, it's under math. So if you hit math, which is down below alpha, it's going to be number 4, cube root. Or you could use number 5, which means you could take the 4th root, the 5th root, the 6th root. 9 out of 10 times, though, again, you're not going to have a lot of TI 84 practice necessarily. Math, mode, and table or graph is where most of our fun stuff happens. Stat is pretty good too for old school stuff, but for math 3, most of it is going to be under math mode. You're going to use your second key, y equals, and graph. Those would probably be the 4 most popular keys for math 3 stuff if you end up choosing to use it. Now, SOAP stands for same, opposite, always positive. Doubled up our P there. Same, opposite, always positive. I'm going to rewrite this guy so he's in our favor. We're going to have a binomial and a trinomial. Same, if this is addition, this will be addition. So they're same. Opposite, always positive. So these two in the front are going to switch depending if it's a sum, so if it's addition, or if it's a difference, okay? So these two will always be relative to this guy, the last one will always be positive. Now we're going to take the cube root of x cubed, and that's going to give me x. And then we're going to put x squared here. This is going to be our ax, and this is going to be our a times b. Mess this up. This is a, this is b. Oh, this is c. A squared, a times b, it is b. A and b, a times b, and this is b squared. Okay, a squared, a times b, b squared, ab. So I guess that would be the other pattern we have to memorize. A being whatever the square root of the first is that our a? And then the cube root, I said square root, see I just did it too. Cube root of 8. So what number times itself 3 times gives us 8? That one is 2 times 2 times 2. Other cool parts with cube roots, they use the same numbers there as well. You won't see it fast, but if you pay attention, it is the exact same numbers over and over and over again. So the cube root of 8 is going to give me 2, so that's my b value. A times b is going to be 2x. And b squared is 2 times 2, which is going to give me 4. You have now factored. Sometimes you can continue to factor. Like in this case, this looks like it might be factorable. No, it cannot because it's a positive 4. 2 times 2, 1 times 4. Nope, not factorable. So we're done. Later along in class, though, do know, like as we progress and get harder and harder, that trinomial sometimes will get more, like it might be able to keep going faster, further. All right, I'm going to skip this one because those numbers are big for the moment, and they just look scary. I'm going to rewrite this one. And I'm going to flip it around and make it what I want it to be, because that's not what I meant for us to do this early in the game either. So we're going to have a 2 and a 3. This is subtraction. Same, opposite, always positive. Again, if you can get that much down, if you can memorize that much within the first day, you're still making huge strides, right? Same, opposite, always positive. This is our a value. This is our b value. Talking about this is a, this is b. This is a squared. This is a times b. And this is b squared when we're done with it. Once we get them all broken down. I'm going to take the cube root of 27 and the cube root of x cubed, which is going to give me an x. We know the cubed of like x squared, the square root is x. The cube root of x cubed is going to be that guy. So what number times itself 3 times will give me 27? That is 3 times 3 is 9 times 3 is 27. So the answer is 3. So it's going to be 3x for our a. A squared is 3x squared. Depending on where you're doing this, more times than not, they will not leave it like this. It will be 9x squared. They will go ahead and square the 3 and square the x. And then we have our b, which we're going to take the cube root of 8 again, which hopefully we saw was 2 times 2 times 2. That's going to be in our b spot. A times b. So a is 3x. B is 2. So that's going to give me 6x. And then b squared is 2 times 2, which is going to give me 4. Don't panic if all of a sudden you're freaking out. This is new, but you have more practice tomorrow. I'm giving you a front run on it, okay? So you'll see lots more of this tomorrow.